Hello everyone, my name is Huang Jigong, a PhD candidate from University of Kentucky. Today I'm going to introduce my paper, Aggregated Generic Load Curve for Residential Electric Water Heaters. I would like to thank to my PhD advisor, Professor Dan Ewnell, my colleagues from my lab, and the project collaborators from Smith Corporation. The electric water heater always causes the residential peak load as its resistive element has the rated power of 4 to 5 kW. Incorporating the electric water heater in the demand response could lead up to 30% reduction in the battery energy capacity for the home energy management system. However, the unpredictability of customer behavior makes quantifying the benefits of controlling the electric water heater difficult, as the user comfort must be met by keeping the hot water temperature above a certain level, typically 150 Fahrenheit. In this paper, we propose a generic load curve for the aggregated electric water heater power and the dynamic monitoring for the water tank temperature. The experimental data was from a project run by Smith and Lowe's during a period of 2 years with more than 800 users. The generic load curve was defined by 8 points based on the experimental data. The generic load curve can be applied to any number of water heaters, and shown together on the power curve are examples for 450 water heaters. The base power was calculated using the number of water heaters, the average daily water heater electricity usage, and the hour of the day, which is 24. For example, if the total number of electric water heaters is 1000, the base power value is calculated as 458 kilowatt. A demand response study was carried out based on the generic load curve. On the curve shown on the top left, the morning peak at around 6 a.m. was shifted to the afternoon when the PV generation was supposed to be high. As a result, the average tank temperature, which was shown on the bottom left, dropped at the shading period and resumed in the afternoon. In this extreme case, the temperature dropped too low and it was less than the minimum requirement, which was marked by the red dotted line. The energy usage for both with and without demand response case were the same at the end of the day, as shown on the top right plot. Conclusions. The aggregated generic load curve for the residential electric water heater load were defined by 8 points. The generic load curve were used for demand response while monitoring the tank temperature. The residential setup was considered a virtual power plant with the electric water heater regarded as a uni-directional energy storage. The electric water heater could absorb surplus PV generation, reducing the required battery energy capacity for the home energy management system. Thank you very much for joining my presentation.